In previous videos, we discussed how the U.S. Army Corps' New England District Disposal Area Monitoring System, or DAMOS program, uses a tiered monitoring approach to understand the effects of placing sand, mud, and silt dredged from the nation's waterways and harbors on the seafloor. DAMOS employs this tiered process to study placing material and to assess seafloor recovery. The first stage of the step-by-step process is hydroacoustic surveying, which uses sound waves to explore and map the seafloor. In the early days of maritime exploration, sailors mapped ocean depths by dropping a lead-weighted line into the water, providing crucial measurements for creating early navigational charts. As technology advanced, more sophisticated methods were developed. Basic single-beam echo sounders, like fish finders, were introduced in the mid-1900s. These devices emitted a single sonar beam that bounced off the seafloor in a narrow strip. By measuring the time it took for the sound to return to the boat, ocean depth could be estimated. Simple topographic charts were then created by drawing out these individual lines of sonar data and estimating seafloor depth between the measured lines. To overcome the limitations of single-beam technology, multi-beam sonar systems were employed, starting largely in the early 2000s. With these systems, during hydroacoustic surveying, instruments like the multi-beam echo sounder are mounted to or towed behind a research vessel. As a survey track is followed, the system emits sound waves that fan out, covering a larger area of the seafloor. The device records the time it takes for the echoes to return to the vessel's receiver, and by combining the recording data with measurements of the speed of sound through water, surveyors create more accurate maps of the seafloor. DAMOS scientists use this technology to monitor the settlement of dredged material placements. Each time dredged material is placed offshore, the location is recorded through the Army Corps' National Dredging Quality Management Program. DAMOS scientists review these locations and plan regular surveys to map and track changes to the seafloor at each site. The DAMOS program is then able to determine if dredged material was placed as permitted and if it's moved by currents or storm activity over time. Hydroacoustic surveying can generate several different types of maps, depending on how the data are processed. For example, bathymetric maps provide a visual representation of the underwater landscape and information about disposal features. DAMOS scientists sometimes intentionally magnify depths on these bathymetric maps. This is known as vertical exaggeration, and the effect can be turned up to increase the visibility of subtle seafloor features, such as disposal mounds and craters. As the multi-beam sonar pulses contact objects on the seafloor, they create echoes that are also detected by the receiver. The strength or intensity of the reflected sound waves, known as acoustic backscatter, tells scientists more about the seafloor. The collected acoustic backscatter information may be visualized as grayscale or color imagery, where darker or brighter areas represent different levels of acoustic energy. In the map shown here, we see stronger backscatter returns over the coarser and harder materials, and less intense colors illustrate where softer or smoother sediments occur. Side-scan sonar, another hydroacoustic survey tool, uses similar technology to create detailed visual images of the seafloor and underwater objects from acoustic backscatter. When used in conjunction with a multi-beam echo sounder, these tools enhance our understanding of seafloor topography and help to identify and study various underwater features, including different types of habitats, such as reefs, seagrass beds, rocky outcrops, and sand. Side-scan sonar is particularly useful for documenting man-made objects, like shipwrecks, underwater cables, submerged debris, and archaeological sites. In some cases, it can also detect schools of fish. Using all this acoustic technology to make comparisons between multi-year data sets helps DAMOS scientists measure changes in seafloor elevations, which is crucial for monitoring dredged material disposal and sediment transport. Overall, hydroacoustic surveying plays a vital role in DAMOS's efforts to manage and monitor dredged material disposal sites by efficiently providing insightful high-resolution maps. This technology is the foundation of the tiered monitoring approach and enables DAMOS scientists to track seafloor changes from dredged material placement, map underwater habitats, evaluate the success of beneficial use projects, and support management decisions. To learn more about the program, please visit the DAMOS website or explore the rest of the DAMOS video series.